Well, I really wasn't ready for that counter to hit 0. Not even close. I fell into the trap of pressing the button that starts the countdown and then got distracted. And I glanced up and it was going 3, 2, 1, live. Okay. I haven't even had time to do like the cough or whatever beforehand. Just a second. Okay. 1 frame per... Really? The buffer. Are we buffering? No. Bufferization active. That's no good. What would be causing this? Yeah, low frame rate. The weird thing is that okay, I'm going to do a bit of an inception thing. Look at this. I'm going to pull the the YouTube streaming interface up and it says excellent connection. Look at this. Excellent connection. And yet I can see in the preview that it is stuttering. So, yeah. Oh, and that. This thing we will get to in a second. But first, drop down to mini face cam. I wonder if this is... Yeah, well the thing is that at the moment... Oh, I know why. Just a second. Oh no, that's not it. Disk off. I'll see if that makes a difference. I'm not actually streaming out of the ATEM at the moment. I'm streaming from OBS. Yeah, I'm streaming from OBS, which has not given me a problem up until now. Okay. Where is the fault? Where is it? I don't know that there is something that I can do about this. It just came good? Okay. So what I did was I noticed that on the ATEM it had the external disk turned on and there isn't even a disk plugged into it. So I don't know what that was doing. I turned it off and now it seems fine. So maybe the problem is the ATEM looking for an external disk and it doesn't like it. Don't know. Doesn't like it when it doesn't find it. So, okay, before I get too much further into it. First, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Just keeping it front of mind. I know every now and then people get pissed off that I do that, but I do it to keep it as something that is a reminder to myself. All good now. Excellent. All right, so, okay, I'm going to go full face cam and shock everyone and see if the frame rate drops back down again. Yeah, that's a good idea, Jax Tech. So, where am I? I'm going to quit out of that. Good morning. Yeah, the TTS is having trouble loading. It's been sitting here. I'm just going to hit reload on it. Maybe there is some connectivity problem. Suitably shocked. Don S. Hello. Okay, the TTS is sitting here doing this. Loading. It's got some information. It's telling me how many viewers there are. But yeah, it is possible that there is a legit internet connectivity problem right now. Okay, so I'm going to, where are we? I'm going to switch to live chat. It always switches to top chat when I pop it out. Good pre-buffer size. Okay. Good morning to, and this is not going to be an exhaustive list because I don't have the exhaustive list. Crispian, Jax Tech, Henrik, Don S, Stephen W, Michael Wise, John Whips, David Kaiser, Tebraze, Austin, good to see you, Austin, Stephen George, Gavin Jackson. I might repeat some names because my short-term memory does not exist. Johnny Bergdahl, David Kaiser, Alistair. Oh yes, I saw your post on Facebook, Alistair, about the car accident. The car just sitting there parked, minding its own business, not causing problems for anyone, and someone just drives into it. That would really screw up your plans. Who else? Sasha Smart, going back up the list, Michael Wires, and Russell Rennie, David Howes, going back, Matt W. I'm sure I saw Amanda in the list further back up there as well, back towards the top. Oh, Imi is here, yes, Amanda, and I think that's it. Alistair said, acknowledging the people from whom the land was stolen is the very least we can do. It's unclear how we as individuals can fix the systemic issues that plague them. Yes, I concur. So, acknowledging and recognizing the reality of what has happened, I think, is the bare minimum. It is not sufficient, but without it, yeah, it is the start of whatever else can follow. Can you open TTS in a different browser? Asked Henrik. Maybe, but I don't know. I actually don't know what the authentication is for it. So I relaunch to update. No, I'm not going to relaunch Chrome in the middle of a stream because I've got. Oh, here it goes. It's come up. It hasn't got the chat yet, but at least it's got the members. Crispy and Henrik. All right, I'm just going to click off a whole bunch of names here. So I have, okay, a couple of things before we get to the conveyor belt. The conveyor belt is there and it is doing stuff, as some of you saw on Discord, because I published some stuff on Discord, posted a couple of little videos. But first, just looking, what have I got? Camera uploads, a very quick update on, all right, 2 things, 3 things, 4 things. I don't know how many things. We'll just do the things and then we'll figure it out from there. First, I am making this decision right at this point in time. I have been undecided right until now. I am deciding right now to skip the barbecue this month, which is next, it was going to be next Sunday. So if you are planning to come to the barbecue next Sunday, I'm sorry, I'm not going to do it. I've been thinking for a while, and a couple of people have suggested that what I should do is switch to every second month, because the cadence is just too high. It's at the, each time it comes around, it feels like I've just recovered from the last one, and I don't want it to be at the point where it feels like a burden. It should be something that is fun and like a special thing, something that I get excited about. And I do get excited about it because it's really cool to see people in person, but it's exhausting, just because of my brain. I'm a social introvert. I love talking to people. I love hearing about what they're doing and what's going on in their lives, and talking to people face to face is a really cool thing, but it drains my energy and then I've got to recover a bit. So I then need solitary time to recover from it. And I'm just finding that doing those events every month, effectively like every fourth weekend. The entire, even though the barbecue is from the stream through Sunday afternoon, it ends up being the entire weekend realistically, because I spend Saturday reorganizing stuff in the factory, clearing things, buying supplies, all the miscellaneous things. So it ends up being an entire weekend event every fourth weekend, give or take. And it's just a bit too much. So I think going to, and also I was thinking about which months it should be, because if it's going to be every second month, and I've been thinking specifically around the Christmas break, it's hard to do a barbecue in January, like start of January, because people are often still away. It's hard to do a barbecue in December because on those weekends there are constantly Christmas events and different things going on. So like second Sunday of December is a terrible time to have a barbecue. Everybody's doing events. So I think the schedule to go is January, March, May, etc. So start on the first month and then do every second month after that. And if that's the case, this is the month that makes sense to skip and then switch to an every 2 months. In fact, what I am going to do, I have said this a number of times, that superhouse.tv, I am going to make a page on the Superhouse site and make it, so it'll be just superhouse.tv/barbecue. Like right now, if you go to that URL, this is what happens. There is nothing there, but I'm going to make a barbecue info page with the dates for the year and just general stuff, because at the moment I have people coming along from different walks of life. Many of the people who come are from my gym or friends outside of this context, and I don't have a way of telling them all that it's not going to be on, or schedule changes or whatever. And Stephen says, I resent the assumption that I have things to do and events to attend in December or January. No, there's always stuff going on at that time of year. And Crispian said, what about quarterly? Yeah, that's been suggested as well. So quarterly is another suggestion. But for now, given the state of everything, which reminds me, that's what I was about to bring up. Hang on. I'm going to show you a few things. So right now, this is the state of the factory. And this, I'm just going to find some photos. This. So I've been putting plasterboard up, and this, and there is stuff just stacked everywhere. This was yesterday. I put these sheets of plasterboard on. Yesterday? No, Friday evening I put those sheets on, and this is standing like at the back of the factory looking towards the front. Down on the right hand side here, just out of view, where this grey bar is, the edge of the picture, that's where the roller door is at the front of the factory. And you can see that there is just stuff stacked everywhere. And this is looking also from the back of the factory towards the front. This is the wall of the clean room, but from the outside, and you can see there's now a plasterboard sheet on it. This photo was yesterday. Since then, I have mudded all the joints. So this now has tape on it and jointing compound, and then I've sanded it back once, and then I put a second coat on with topping compound, which is drying right now. I put it on this morning, and it's starting to look like a proper wall. But yeah, this is what the factory looks like right now. Yeah, just stuff stacked everywhere. It is a total chaos. And if if I have an extra month to work on it and I get it all sorted and get the carpet laid and walls all finished and get benches in, then if I do a barbecue next month, it should be looking pretty schmick, and I won't be so ashamed of people coming along. So TTS got tired and went on vacation. Yeah, it's doing this. I reloaded. Oh, Sion's here too. And Mitchell, Russell. I've already said hello. Gavin, I think I've said hello to. Oh, Mike Harden's here too. Just clicking these names away. I'll try reloading again and see if it gets the chat this time. Ah, yes. Sion says, I say you should have the barbecue today. Lots of free space to hang out. Yep. Still not loading. Oh well. So that is the that is the state of the factory right now. Yeah, it's a big mess. I need to find places for a lot of this stuff. There is so much stuff here that I don't want anymore. And no, I'm not talking about all my power tools. So nobody lay claim to the power tools. But there's this huge server rack right there. Can I zoom in more? No, I can't. That's at max zoom. There is this huge, it's a 45 unit server rack with glass front and back doors. It's only got one side on it. It's got a cooling extraction system on the top, like heat extractor. Yeah, I want to get rid of that. And there are a couple of big benches in here that I don't need that currently have things piled on them because there's nowhere else for the stuff to go. Because there is no shelving, because everything is pulled off. It's a mess. So anyway, my point is, I'm going to create a page and I'll make it at superhouse.tv/barbecue, and that can be a place that I can just post whatever the plans are for the next upcoming barbecue and times for upcoming ones. Yeah. Oh, David says, lovely metal benches with giant wheels on them. Make great workshop benches. Yeah, they do, but I've got too much, like too many benches. I don't have that much room. I have a surfeit of benches, a surplus of benches. Claiming their drill. Oh, Don S says, I'll come over for a visit when that is all done. Awesome. Oh, Tassie Bob's here too. Yep, the TTS, now that I've tried to do the reload, it hasn't even loaded the list of names this time. Do another shift reload. See what happens this time. I'll let that sit and do its thing. Alright, so in future, check superhouse.tv/barbecue. I will make that page hopefully later today. Workshop bench races out on the road. Yep. Yeah. Oh, Mitchell. Yeah, it probably wasn't you. It's probably my internet connection. That's my explanation anyway. Because when I started this stream, I was getting a couple of frames a second. It was buffering big time and had lots of problems. So, and then it came good. So maybe it's just like a weird internet connectivity problem. I know what it is. It's the tariffs. the tariffs on exporting the data from a US data center. Tassie Bob, one day I'll make it across the pond for a barbecue too. You'd better. Yes, you got to come and visit sometime, Tassie Bob. Oh, Jack Seck said the barbecue Discord channel could also be revived. Yeah, I have posted in that once or twice. Right. Okay, where are we? Barbecue. Oh, Austin just posted in Discord in the barbecue channel. Thank you, Austin. You're doing my job for me. So there was another thing. That's right. this morning when I woke up, I was, I'm just going to open a couple more pictures of Stephen Hawes. So I just took a couple of snapshots. These are screenshots from a video. So Stephen's just published a video about the design of the larger pick and place feeders that he's doing at the moment, because there was a problem with taking the design that worked well for his 8 and 12 millimeter feeders and then scaling it up to larger tape, because the tape path was twisted and it just didn't work very well. So anyway, I was just watching a video of his this morning when he was explaining this design update. This is part of the feeder, the peeler mechanism. That is not the point. The point, Stephen, get out of the way. The actual reason I took this screenshot is that I wanted a photo of the bench that is behind him and how that is set up. It's a very minimalist sort of workbench. I don't know where this is in their factory. It looks like it's a bench that's just used for a bit of casual work. There's a little bit of gear, not very much. It's not like someone's 9-to-5 permanent workbench. But there were a couple of things about it that were interesting, and one of them is if you look down here. Oh, you can't see. Hang on. I've got to zoom. Come on. Why can't I zoom? What is wrong with there we go. My trackpad is not working properly. There is this, what looks like a 3D printed thing in Majigami with a whole lot of tools in it. And anyway, I just saw this in passing as I was watching this video and went, oh, that's cool. And you can see that there's also fume extraction and other good stuff on there. But yeah, I just saw this little tool holder thingy and I snapped this screenshot because I wanted to keep a record of it to remind myself later to revisit this. So, doesn't look like he has removed the blue protective film on the metal. Where's this? What are we talking about? Needs to refresh TTS. Okay, I will try refreshing TTS. Here we go. Alistair says, I love how excited he is about the stuff he does. Yeah. Stephen is so excited. Always. It looks, oh, hang on. Let's see. I'll just load this. Loading. Yes, TTS is back. We have the full list. David C is here as well. The blue protective film on the metal used to make the bench in the photo. Yeah. It's like a thin film that you peel off when you've finished with the thing. Or when you're ready to use it and it's still got the film over it. Although maybe not. No, maybe it's painted that way. Look at the...
Outside the box said, woohoo.
If I drag this across here, you can see that even the drawers down here, it's all the same color. So maybe it's like a powder coat finish or a paint finish or something. Yeah. I like the way he's got the alligator clips along here as well. It's a little bit different. Oh, and where are those test leads going? I don't know. Anyway, I like to look at people's workbenches. There are often little bits and pieces that give me ideas. So one thing that's good about this is lots and lots of light. You can see how well illuminated that bench area is. It stands out in the background behind Stephen, even though he's probably quite well lit himself for making the video. And even compared to that, the workbench is quite bright. Ooh, hang on. Are we going to get music? Let's see if the TTS is going to do this. See if Henrik's thing does it. Okay, I'm going to continue and maybe it will. Maybe it won't. So, oh, barbecue. Okay, I'll leave that open for myself to remind myself later. When I see that page in the browser, I will... Yeah, the TTS doesn't seem to have caught up. Hate your all. It's slowly doing its thing. Okay, what else was there? Oh yes, so this was a comment on the live stream from last week. I'm going to just zoom in on this a little bit. This is one of those messages that when I read it, I thought, how do I describe this? It made me wonder if I suddenly got stupid. That's the best way to put it, I think. I read this and I thought, my brain isn't big enough to comprehend this. It seems really clever if I could only understand what is going on. So Frederick Uppenstein, sorry, or Umpenstein, I'm not sure how to pronounce that. Frederick said, so okay, context. In the stream last week when I was working on the firmware, so Henrik, I'm still hoping that your thing is going to come through on TTS. Henrik has been a member for 11 months. And, oh, hang on. I have, I've got to reply to this. I've got to reply. Hang on. I will explain. Hang on. Earliest I can be there is about 12:30. Okay. Sorry, I'm in the process of buying a guitar, another one, and I had arranged that I was going to go after the stream to hand over the cash and pick it up, and that message is from the seller saying he's got 4 other people waiting, and when am I coming over? So I just had to reply and make sure that it didn't get sold while I was on the stream. Okay. Mr. Fix-It says, just got back from buying a 40 kilowatt laser engraver new for $250. Awesome find for the new lab. That is ridiculously cheap. So you new for 200, what? That's like a couple of grand worth of laser, maybe. Well, I don't know what the current market is for those, for the K40 style, but that is ridiculously cheap in any case. No, I just got a confirmation that, hang on, I'm just going to say 1 p.m. is perfect. Yep, cool. Okay, Mr. Fix-It says sells on Amazon for $800. Alistair says no, K40s are around 500-ish. Yeah, okay. They are cheaper than I remember. It's been many years since I looked at those. First, Henrik, when can we hear the first Superhouse TV single? No, never. I am not playing on a live stream. And maybe one, yeah. I was going to say that's like famous last words. Maybe at a barbecue. What I need to do is get, there are a couple of people, so last weekend, was it last weekend or the weekend before? I can't remember. I had a jam session with a couple of friends, one of whom comes to the barbecue fairly regularly, and the other one has never been to the barbecue but really should. Because he's into this sort of stuff. It's just that it doesn't work out that so far it hasn't worked out that he's been coming along. So what I should do is, I've been thinking for a while. I've told you before on the stream that there is a band that practices in the factory, like 2 factories away, just on the other side of the coffee factory. And I went in to talk to them once when they were in there practicing, and talked to them about coming in and doing a performance at a barbecue, at one of the barbecues, and they were interested in it. So So yeah, live band at a barbecue. That's my plan. My plan then though was not that the live band would include me, but maybe it could with a bit more practice. So this, okay, context. When doing the firmware last week, I was debouncing. In fact, I'm going to open the source code for the firmware. And what I was doing was debouncing on the sensors, on the board sensors on the conveyor belt, so that when the leading edge of the board begins to pass over the sensor, there is some fluctuation in the value that comes back, and it can false trigger. Oh, excuse me. So where are we? I'll get rid of that. PCB conveyor 2. Okay, this. And where are we? PCB sensors. So we're reading from the sensors, read PCB sensors. It does the ranging, sets whether it's tripped or untripped, and then in the check, where is it? Here we go, state trend, if tripped is exit sensor, no, entry sensor. Here we go. Yeah, so this was the crude thing that I did last week, which was just saying if it's untripped on the exit sensor, then we increment the count, the exit sensor count, and then if we have exceeded a debounce count, then we set it back to 0 and we do a state transition. And if it goes out of that, so if it becomes tripped again, we reset the count. So basically what that means is that we need a consecutive unbroken series of consistent readings on that sensor before it's considered to be valid. And that introduces some delay and things because we don't actually see the change in that sensor for quite a while. John Whip's idea, where was this? Band name Jono and the Squirrels. But the customer. Okay, so so this was the crude debouncing that I put in place on the stream last week, and this is the comment that came in. This was a comment that is on that video from Frederick, and I will just read it out. It is, my favorite method of debouncing is something like this, definitely at the reading the sensors location, is to shift the current state through a byte. Hex FF equals 1, hex 00 equals -1, anything in between is bouncing and reports as 0. The value is truthy once it's debounced. The sign gives a state, and I can use greater than or equal to 0 for a quick low-high edge detection, or greater than 0 or 1 for a debounced high. For your 10 stages, just use a larger integer, shift the current state in from the top, and then assign shift to the top n bits down to 0. We'll give you a simple 0 or -1 to test for. That also makes it possible to ask for n bits of debouncing on a situational basis. Okay. I've read it. There were words in it. I think this is smarter than I am, whatever is going on here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we've got 8 zeros here, which is a byte. So we could say uint 8t. No, it'll be an int. It'll be an int. Int 8t. This is not real code. I'm just going to do pseudocode here to try to. And it's just like a. What is this? It's a text editor. It's not even in a file. I haven't even saved it. This is just a scratch pad to get the idea into my head. So what are we going to call this? We're going to call it sensor transitions, that'll do, equals something like that. Okay, so what we've got is an integer which has a value of, so it's an 8-bit signed integer, and yeah, it's a thought exercise. That's right, Michael. It's me trying to comprehend Frederick's suggestion. So if we had, I'm not even sure where to start with this. Okay, so anything in between is bouncing. All right. You use a larger integer. Shift the current state in from the top and then assign shift of the top n bits down to 0 will give you a simple 0 or -1 to test for. All right. We've got 0x ff = 1, 0x 00 equals -1, and anything in between is bouncing. And reports as 0. So then it gets fully shifted or fully cleared. Yeah, well, I'm not sure. I don't think I'm going to use this technique, but I'm interested. This is just a fun little exercise. I'm just trying to understand what this suggestion is and how it works. And you can all laugh along at me muddling my way through it. So a bit more buffer. But buffering. Oh no. Oh no, we've got buffering going on. That's no good. Oh, and Peter Kirkos has arrived as well. Welcome to the chat.
Buffering.
TTS worked. Hang on. We missed out on... where were we? Yeah, we missed out on the... yeah, Henrik just said lots of buffering here. Buffering. Sorry, I'm looking for the YouTube window to see what it thinks. No, it still thinks the connection is okay. Odd. All right. Now, if we... Yeah, I'm still trying to get my head around this. I think what I need an example, which is what I'm in that's what I'm attempting to create here. So if we did something like, okay, imagine that we're just reading a switch. Forget that it's a distance sensor or anything like that. We're just reading a switch. So if we did something like, if, and what are we going to say? I'm going to say one tripped, 0 untripped, just for the sake of this exercise. So if we said
only buffered while you were trying to figure out that code.
Yeah, that was my brain going dit 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 dit. So if we say
Amelia, Imi's sister, is here and says hi.
Oh, hello Amelia. So if we say sensor transitions, how about we do sensor transitions left shift by 6 or 7? I think 7. And then we do, well, you can't actually do that syntax. I should try to make this, let's do, I'm sick of typing that. S-trans, let's do S-trans just because it's less to type. So I'll do S-trans equals S-trans bit shifted left 7 times, and then we'll do strans plus equals, say digital read on sensor pin. Once again, I'm not compiling this, so I don't have to declare stuff. So sensor pin, so strands, so we shift, no, okay, no. We shift left once. We shift left once. Oh, let's see if this works. Jacksec says, I believe the technique is called bitwise integration debouncing. Yes. It worked this time. Thanks, Henrik. She should be more chuffed now. Thank you, Henrik. Yeah, we missed out on it from your membership thing earlier when everything was like kind of going crap. Bitwise integration debouncing. Okay, so I'm going to add that here. Bitwise integration debouncing. All right, so we do so we bit shift 1 left to move everything along, and then we add whatever the current reading is. All right, so to give some examples of that, say we had the current value 1, 2, 3, 4, 5, 6, 7, 8. So we've got an 8-bit doing this as a signed bit, like as a signed thing, is what's confusing me. That's what, yeah, it's the, so that is 1, that is -1, but hex 0, 0 is not -1. And you can use greater than or equals 0 for a quick low to high edge detection, or greater than 0 or 1 for a debounced high. My brain is just not comprehending this. Looking for overflow of minus. Yeah, but how does the overflow help? That's the bit I don't get, is why does the doing it as a... So if it overflows... So, okay, we've got an 8-bit byte here, but it's signed, which means that the top bit is going to be the signed bit. So if you had 7...
Tabraze Malik said, read my comment, John.
Okay. Yeah, it's adding powers of 2 while a button is pressed and looking for overflow, -1. Yes, that, but I still don't understand how that helps. Because say we get 7 consecutive high readings, we end up with this value, which is 127 in decimal, and the sign bit has not been tripped yet. But then you get, say you get a...
Unexpected Maker said, as exciting as this bitwise stuff is, ultimately, you can't share code that people can't read or understand.
Yes. Sion is correct. I should get on with actually just doing it. But when I saw this comment, I thought it's an opportunity for me to understand something new. All right, I'm not going to spend much more time on this. I just want to do one more little step on this. So say you then subsequently got another reading. If that reading was tripped or untripped, doesn't really matter. What's going to happen is, because of the bitwise shift, so we're doing a bit shift to the left by 1 step, we are then going to have a 1 in the sign bit. So it's going to become 1, 1, 1, 1, 1, 1, and then whatever the next reading is, which could be 1 or it could be 0, it doesn't matter. So this then becomes, so that is minus 127, or is it 126? I can't remember. I so rarely deal with signed signed math. So that is 127 127. So that must be 120 minus 126. So if we get a value of 127, but if, for example, you got that, you would end up with a value of 126.
Smack the dislike button and unsubscribe.
And that does not solve the deep... Yeah, anyway. This is beyond my brain at the moment. So... Stephen says, wouldn't you just look for an FF or a 00? So long as they're all the same, that then triggers a state change in the code. Yes, minus 1. Paul. Oh, Paul is here in the chat too. A person whose brain is definitely bigger than mine. So, oh, and Pete is here as well. So Paul says it's mapped 0 hex 00 to FF to minus 1 0 1. Then the decisions are made on the mapped value. Oh, Keith. And Keith is in the chat. Keith said, this week we made a footbridge of acrylic to check penguins' feet. Nice. Yeah. For those of you who don't know, Keith has mentioned it at a barbecue in the past. Keith does some work with penguin colony things. Tabray says, it could just be left shift the button state 8 times. 1 for press, 0 for unpressed. FF is minus 1. Yeah, okay. Anyway, I'm going to get off this subject. And no, I'm not going to delete that. I'm going to leave that and just minimize it so that it is there until I find it again in the future, and then look at it and shake my head and think I don't understand and give up programming because I am not smart enough for it. So let's have a look at, I'm wondering if I should move the sensor count debouncing into the sensor, into the PCB sensor section here, because we're about to have to do stuff. All right, now, what I want to do, now that we're almost halfway through the stream, is begin. What I want to do, okay, first step, I'm going to show you what I got working after the stream last week. So last week was a 4-hour stream, and even that wasn't enough for me. So I kept working on it after the stream, and I basically spent the rest of the day on it. And I got some cool stuff happening. So let's switch. What am I going to switch to? This view. Okay. Now we have the conveyor, and I've put the second motor on it, so it's got both belts and they work. It's currently set to a width which is suitable for some panels that I just happen to have lying around on the bench. Not even the same width, but they're close enough that they work. So I can chuck a few. These are things that have been partly pre-assembled. What else is there? So we've got the controller here. There's nothing on the LCD at the moment. I've had these controllers keep crashing on me. I don't know why, but I have had terrible luck with these touchscreen ESP32 things. They just crash constantly. So I'm going to power this up. In fact, I think it might already be powered up. No, it's not. I'll power it up from there. So it's now got power from, does it? Yes, I can see LEDs are on. So that is now running, and I've got to remind myself what is going on. So let's just come over here and get ourselves a console port. Yep, that'll be the one. And pull up a serial monitor. Over here. I am just going to also grab that, and put it up here so the chat is on screen, and then everybody can see me ignoring the chat. And okay, now what were the commands? Where is the G code? All right, after the stream I reconceptualized a whole lot of this stuff and updated some of this documentation. We've got all these different commands, and I broke it up into major sections. The first one is just, well, the first section is these ones, G28 for home and G0Y blah to send the conveyor to a certain thing. Then I've got the single digit M codes, which are just direct speed settings. Then I've got some unused ones, clamp and unclamp. I only did that to reserve those codes, even though I don't have or plan to have a clamp on the current thing. And requesting status of a sensor, which is not yet implemented. Then I've got the 5 series, which is different modes or different requested operations. So for example, M50 at S blah. Also, I added the S parameter. This was after the stream. I added the S parameter to all of these commands so that it's no longer necessary to do something like set a speed and by telling the conveyor to move and then stopping the conveyor so that it has the speed set. That just seems silly. So now you can just arbitrarily say like M50 S800 and it will do a load to the middle with at speed 800 millimeters a minute. So there's no direction argument on here. It assumes left to right, which is a whole other thing, which can be dealt with in future. So what we've got is unload immediately is implemented. I'll drag this out a little bit wider so we can see those comments. So what I've done is defined, I've pre-allocated some of these M codes, but I haven't done anything with them. So we've got all of these marked as not yet implemented. Unload immediately on M54 works. Unload at a timed interval works. And those two are cool. So M54 S speed. So what this one does, so what I did was implement those two state machines. We've got unload immediately and then stop. That's what we did on the stream. And then unload at a timed interval is what I got working in the afternoon. So what is it? M56 S speed P dwell. So the P parameter in G code is called the dwell, which is like a delay or a time, but P works out really well because you can think of it as being pause. So if we do a command, I'm going to, come on, I haven't actually tested this since, so I'm not going to hit enter yet. I'm going to wait until we've got the view. So what I'm going to be doing is say M56 S800 P5. So what this should be doing is unload at a timed interval at 800 millimeters per minute with a 5-second pause in between each unload. So if we have a number of boards on the conveyor, it should spit a new board out every 5 seconds, just on the regular. So back to overhead view. So what I'm going to do is just chuck some boards on here, and just to show you, I'm going to have this is something that I changed. I'm going to have a short interval between these boards and then a bigger interval between these boards. I'll just lean over and press enter, and then of course nothing will happen. Hang on, I've got to get focus in the window first and then go. Oh, it is going, okay. So it's going to throw off the first board, and then it will bring the second board to the end and pause. So it specifically runs until the next board is queued, and then it did the 5-second pause, chucks it off. It'll run until this board reaches the end, and then it will pause, 5-second pause, and then it will throw this one off as well. And if I chucked another board back here somewhere, it'll keep going until it brings that one to the exit point, so over the exit sensor, and then pause, 5 seconds, spit it out. So the use case for this is if you wanted to, for example, send boards, and then it's got a 30-second timeout. If I just leave this running, I can send a command to tell it to stop. What it's doing now is trying to bring the next board up to the end, but there is no board, so it's never actually going to get to the point where it pauses at the end. So after 30 seconds, that will time out and stop. Or I could send it an M5 command, which is the stop command, and then it'll stop immediately. So that is now able to dispense boards on a regular cycle. So I can have boards queued up. Now this is totally ignoring ready in, ready out sensors, like communications or anything else. It is just spitting them out at a time interval. The use case for that is putting boards into the reflow oven. So after they have been manually processed, because what we do is after the boards have been through the pick and place machine, we take them and put them down on a bench and then manually put the last couple of parts on, whatever they might happen to be. You know, parts that that might be oddballs just for that particular project, or they might be parts that the pick and place machine can't handle because I don't have feeders set up for it, or whatever reason. There will be some manual intervention, and then we'll end up with a whole bunch of boards that need to go into the reflow oven. The thing is that the reflow oven needs to have the boards come in at intervals so that they are spaced apart, and there is no ready in, ready out communications on the reflow oven. So at the moment I have Xeon's IN6 reflow oven. It's got a conveyor that just runs continuously, and it has no idea whether it has a board on it or where boards are or anything like that. So it doesn't know if there is room on the conveyor. What we need to do is just send boards in at regular intervals, which might be, say, once a minute or whatever the interval happens to be. So with this, what I can do is set up a conveyor at the entrance to the reflow oven and tell it to unload a board, say, once a minute. And then as we have boards that are ready to go, we just put them on the conveyor, and you just keep putting them on wherever there is space on the conveyor, leave a little gap between them, and it'll just output one board every minute to load it into the reflow oven. So that is the use case for this timed unload mode. So that in itself is a very useful thing for our particular workflow, but I need to get ready in, ready out sensors working, because that allows interaction between the conveyor belt and the pick and place machine, both on the input side, so that we could be feeding boards into the pick and place machine on demand, and on the output side to be accepting or buffering boards coming out of the machine on demand. So my plan now is I need to, wonder if I can, no, I'll take it apart. I need to put the relays on the ready in out connections, and I need to activate the optos, which can be done. Yeah, I'm going to have to look at the design to remind myself, because it's so long since I did this. But basically what we should be able to do is have a state where we have boards loaded on the conveyor, and we activate the signal from the next machine in the queue. So imagine that we're simulating being a pick and place machine. We have to send a signal saying, hey, we are ready to accept a board, please send us one. The conveyor should then send a board and stop, and then wait for the next time that it is asked for a board. So, hang on, I'm just going to have a quick look at chat, because I think there might be stuff there that I've been missing. Oh, stop reminding me about Java. Oh, and you can see here, this is the debug for the, so I sent it the command m56805, setting speed to 800, and these are the states for the state machines, for the state machine. Now, what you can see is this is an M56 command, and I defined the states as matching the M code command. So if we come down to here, and yes, I know enum state definitions. Where did it go? Come on. Oh, here we go. Okay, so M56. These are the states for the state machine when it's doing a timed unload. And I made the numbers for all of the states start with 56. So 560, 561, 562. And here we've got 540, 541, 542, etc. So that's for the M54 command. So when we look at the state machine, we can see the state machine went from state 0, which is idle, to 560. And that is because of the M56.
Said,
no, no, you're going to drive Sion away, Scott. Don't do that. So we went to state 560, which is the first state of the M56 state machine. And then it went from 560 to 561, 561 to 562. This is at the milliseconds since boot, so it's 300 seconds, 5 minutes since boot. And this is the delta. The delta is the time since the last state transition. And you can see, for example, it had been up for 5 minutes when I sent that command, and then it was 122 milliseconds in that state, then 122 milliseconds in that state, 4.7 seconds, 1.6 seconds, and etc. So yeah, we can see the state machine debugging there.
Scott Miller said, "Wahahaha."
Yes, skirting danger. Yeah, so what I want to do, I know I've been joking about it, but I do actually want to redo the way this state machine works to use enums, and I want to make it so that this is more helpful. At the moment, it's saying that the state machine is transitioning from state 560 to state 561, but who knows what state 561 is? You have to go and look it up. Like, you've got to come into the code and find, oh yeah, that is state unload timed. So this prefix is the command, unload timed. This is the command. And then it begin, and then it's moving, and then it's reached end, then it's cleared end, then it's pause. Those are the 5 possible states that it can be in while it is doing this unload timed operation. So what I want to do is have the state machine report the name of the state in this debug. So you can see, oh, I just went from idle to unload time to begin, and then I went from unload time to begin to unload time to moving. So when you're looking at this debug information, it makes more sense. And I think, yeah, so I want to use a better method than this for defining it, using a struct or something. Yeah. TTS slow again? I don't know. Is it? Hello, Jordan. Welcome, Jordan. No? Oh, yeah, TTS seems to be working, I think, as far as I know. So the, yeah, so where was I? That's right. So what I want to do is add support for ready in, ready out stuff. And let's do ryro.h. That's a what am I going to do? Yeah, Ryro. There's got to be a better way to put this, but I'm just going to say, whoops, end if, h ryro, ready in, ready out. So this is going to be where we start doing our stuff for...
TTS always has a slight delay from chat.
Yeah, it does. Where is it? Here we go. PCB sensors, hash include ryro.h. I don't like that name because but calling it ready in, ready out, or what do we call it? Someone give me a better name than ryro. So ryro is ready in, ready out. That is the connection between the adjacent machines so that they can signal when they are ready to accept or ready to send a board. And when they both agree, then they both activate their conveyor belts and the thing transitions from one to the next. Rut-row, Shaggy, the boards aren't behaving. Yeah, Jackstack. So first thing is I need to, what do I need to do? Hello. I need to, I'm going to launch Fusion because I want to remind myself of how those interfaces work. My very rough memory from literally years ago is that I have RTA, RTS, ready to accept, ready to send. Yeah, it's like old RX, RS4, I was going to say RS485. Yeah, that applies too if you're on a multi-drop bus. Yeah, RTX, RRX, there's CTS, CTX, clear to send, CTS, CTR, clear to send, clear to receive. Biro, just write it down. RS232, yeah. Yeah, it's handshaking. Essentially, it is handshaking. Maybe it should be, I should just call it handshake. That might make more sense. So, my memory is that there is an optocoupler on the input side and like a tiny little relay, a read relay on the output side. And I'm going to, no, not Testomatic. I opened Testomatic just automatically. Okay, Conveyor. Conveyor 2.0 DMX. DMX? What is DMX? When do we get to ISA and PCI? Yeah, IR expander. Here we go. Bring this up and get rid of that. Maximize. Come on, maximize. There we go. So where is ready in, ready out? It should be over here. So we have ready in and out left and ready in and out right. I'm going to, what are we going to do? All right, V-switch. So we've got right input coming in through an optocoupler and then going into an input on the I/O expander, which means that in order to trigger this input, all we should have to do is short across that input. And that will simulate the next machine in the chain saying that it is ready to accept a board. Okay, and we don't actually care about this from a signaling point of view. In fact, I'm not even going to solder those relays on because we're not even using this at the moment. I'll implement it in the firmware, but then I'll add the relay later. So on the output side, we have an I/O pin coming from the I/O expander controlling a transistor, turning on a relay. So all we're doing is firing a relay when we want to signal to the next machine in the chain that we are ready to send or accept a board. Okay. Oh, to do, add midpoint sensor, already done. Maybe add spare sensor. Replace sensor connections. Yeah, that's sensor connectors. No, that's IDC now. Check that patch has been applied. Yeah, I need to do that. There's going to be a rev on this hardware. So this is the critical thing. For now, all we need to do is read GPA 6 and we should be able to check whether this input has been shorted. So we've got power coming in, we've got V switched coming in through a resistor. That'll be 12 volts through the 560 ohm resistor onto an optocoupler. So if we do a check on GPA 6 right in GPA 6, we should be able to read that. So have I done any of this in the firmware yet? No, I defined pins and set them to 99 because I haven't actually set them yet. GPA, oh, excuse me, GPA 012, where is that defined? If anywhere. GPA 0, okay, define 0, 1, oh, okay, so it's ports of the I/O expander. So I'm going to need to do that, just so that it's like a 2-layer GPA 3. This is, it's kind of bleh, but I'm going to keep with this GPA 5, and which one do we care about? GPA 6, okay. Yeah, this is a kind of blah way to be doing this, but let's just do it. Oh, in fact, let's do the next one as well, because we've got 8. Do we have 8? I think we might have 8. I don't know how many pins we're actually using on that I/O expander. Where is the I/O expander? Must be on the other sheet. Where is it? We're not using GPA 3. We're using 012 for the time of flight sensors. Okay, and then we've got 4, 5, 6, 7 as being left in, left out, right in, right out. Okay, so keeping that in mind, I'm going to move it. Can I see it? I need to be able to see it because my memory is so bad that I will not remember what that is.
Unexpected Maker said, you should use enums.
Don't you do that to me. No, Sion. Ready in left pin is GPA 4, ready out left. Left out is 5. Right in, oh yeah, it just follows the order. So that makes it particularly easy for my puny brain to comprehend. Okay, so now we can just refer to them as ready in left pin, ready out left pin, etc. Okay, now where am I using this and how am I addressing it? I just want to see how the digital write, okay, so I'm doing that. Digital write. I'll just do a digital read off the MCB 23017. So let's go to roll. What are we going to... all right, I'm just going to do report ready in... that'll do. Report ready in. This is just going to be like a debug thing to figure out whether the hardware is even working, and then it can be renamed, massaged later. So what we're going to do is digital read, read PCB, that is ready in left pin, and I'm going to go serial.print left, and serial.print that, and then just repeat it for the right, kinda, yeah, why not, left, right, and right pin. Oop. helps to do that. And just for the hell of it, because it's not going to be doing anything else, I'm just going to do a delay 100 on there. I know it should be non-blocking code, but this is purely to validate that the that this hardware is working. So let's, in fact, what we could do is down in the loop, we could, where's the loop? Here. Wi-Fi, blah, listen to serial stream, debug, process state machine. Let's do that and get rid of that, get rid of that. In fact, I'm going to get rid of everything because all I want to do is check whether this is working. I don't even know if the hardware is working. So let's make a deal. Let's see what happens. Hopefully we'll get a stream of zeros. Hang on. What are we going to get? Zeros or ones? We're reading from. We are reading from right in and left in. Oh, it's going to be ones by default. So when this is open, the LED is turned off, which means the transistor is off, which means the input is biased high through the 10K. When that is shorted, this will turn on the transistor, which then pulls this low, so we'll get a 0. So it should be reporting 1 on both those inputs. Error compiling. How dare you? My code is perfect. What have I done? Come on, come on. Back to the start of the errors. Back to the start. Do I even have the right board type selected? No, I don't. That'll be why. I'm trying to compile for the wrong target. Okay. Let's see if that makes any difference. So clear that. Where's the chat gone? Oh, the chat has disappeared behind Fusion. Here we go. Active code in a header file. Yeah, it's all header files, Scott. Nothing but headers. Nothing but headers all the way down. Just layers and layers. It hasn't exploded yet. So let's see if we get just a stream of ones. We want ones. And then if I use a pair of tweezers, I'm going to have to figure out where the connection is. Where is the input? Out in... Oh, okay, I can see where the connectors go on the PCB. So I will be able to use a pair of tweezers to just short across them, and that'll simulate the next machine in the chain saying that it is ready. Upload, hurry up, hurry up, hurry up. Hurry up. Resetting off. I'm an idiot. Yeah, let's see if that fixes it. But we are getting ones, which is encouraging. Oh, my chair is sinking again. That's better. Where's a pair of tweezers? A pair of tweezers when I need them. Okay, I am ready. So when I short across one of these inputs, what are we reporting? Left and then right. So if I short across the left input, that should turn on the optocoupler, which then will give us a 0 value on the left input. Upload. Go faster. Go faster. All right. Should be almost ready. Here we go. So we got left and right, and I'm going to slide across here out of sight. Where is it on the board? In. All right, I'm going to short across the in with the tweezers. I can't actually see the console at the moment because I'm looking at what I'm doing. Oh look, we got zeros when I short with tweezers. Okay, now I will short with on the in on the right hand side, and we get zeros on the right. Hooray! So it looks like the ready in, ready out. Oh, the ready in, like the terminology is it's like TX and RX. You can never get it correct. So I think our hardware is working in terms of being able to read those. So what are we going to do with those? We need to process those. Let's rename that that function. Instead of report ready in, let's just do like check ready in, and this function can then set some values. So we'll say, oh, and do I want to define states, or should we just use 0 and 1, which are magic numbers, and it's kind of inverted? I want ready in to be true so that we can say if ready in. So what I'm going to do is invert it, and I'm going to say G ready in left equals, in fact I should have just done it here. Let's make this simpler. Ready in left equals the inverted version of that. How does this strike people? Is it gross? Is it acceptable? I think it's a reasonable ready in left, ready in right. What I want to... The terminology really bugs me. I want to make it clearer what's going on here. So what are we doing? We're setting a... Oh, and it's going to be a global because we're just setting this as a flag for use elsewhere in the state machine. So it can be checked anywhere. We could also call this on demand. So that's the alternative. So what we could do is we could say bool ready in right, and do return opposite of, yeah, I'm just spitballing here, just coming up with ideas for alternative things to do. So we could do something like this, in brackets, so that we could say if ready in right, and then only read that on demand. I kind of prefer that idea. What do people think? It should be G ready in. Where G ready? Yeah. Keith said G ready in. Yes, you're right. Sorry, I'm behind on chat. This code will never get past a code review. The only one reviewing it is me. So stop putting code in header files. Yes. No, that makes me more tempted to continue doing it. So ready in right pin. Oh, dodgy. Dodgy says, just popping in to say hello but can't stay. My brain won't focus on just one thing. Yeah, I know that feeling. Okay. I'm going to get rid of that for now. G ready in left, and I'm going to say, I'm just going to define this somewhere. And live. Serial print ready in left to right, ready in, ready right. Okay, ready in left, right, right, ready to right. Okay, I'm going to paste that in. Where was it? Here. So that was, let's just say void report ready in, and put that in there, ready in T left, T right, ready in left, ready in right. Okay. Next you'll try and write the entire program in a single statement. Yeah. Guru says, well, still going at it today. You thought I was going to miss out. No, this stream has been going since last Sunday. I have not slept since last Sunday. It certainly feels that way with the amount of sense that I'm making right now. Okay, so anyway. Now, what are we doing? Ready in left. All right. This is kind of an ugly way of doing it. But what am I going to do? What am I going to do? Where are... Okay, PCB sensors. Let's just put it here somewhere. Ready in, ready out. Handshaking. Handshake. That'll do. Rule that equals floss. And ready in right is floss. And then those values will be set when loop does this. Yeah, I think I'm going to change that so that it's not... The thing is that with this approach, it is constantly reading those things, even when nothing in the code cares about it. The values are being set in the globals, the flags are being set, even if it's not in a state where anybody is paying attention. So I might change that, but for now this will do. So what do we want? We want to process the state machine, we want to read PCB sensors, set conveyor, read CAN. I'm going to leave CAN bus turned off just for now, even though that shouldn't have any problems. So check ready in. Alright, so now what we should have is values that are being set based on ready in, ready out. Okie dokie. Let's start looking at what the state machine should be doing for that. And what command is it? What are we going to implement that uses this? So now that we have, how about we implement a mode where it will load, and also you can see this was basically just me doing a thought experiment. I was thinking through all of the different ways I might want this to work and then pre-assigning these M-code values. So I've got, for example, two different versions of load to the middle, two different version, oh no, I've got load to the end, move first board on the conveyor to the end. Why don't I have a second version of load to the end immediately? That should have load to the end when ready in and out. That is a major oversight. So M53 S speed should be load to end when ready in out. Yeah, which of course throws off all the numbers, which is why doing this with enums and things would make more sense. So 53, that's going to become 54, that's going to become 55, 56, 57, 58, 59. So we've got load and unload when ready and out, and timed. We've got unload at a timed interval, unload immediately, unload when ready, unload when ready and out at time. Yeah, so I'm looking for sets of things here. I'm looking for different, so we've got loading to the middle immediately or in out, load to the end immediately or in out, move board to the end, unload immediately, unload when ready in out, and unload at a timed interval, unload and unload when ready in out, load when ready in out, unload at timed interval. So yes, so state unload now, is that still 54? I can't remember. No, that'll become 55, unload immediately. So I need to increment these. This sucks. 54, so that's going to become 5, 5, 5, 5, 5, and that's going to become 7, 7, 7, 7, 7, and that is 7. So my M codes have changed, and that's only because I want to keep things grouped. I don't like the idea of adding another M code at the end where it's out of sequence. So, is the answer 7? Yes, it is. The answer is 7. Then we've got, so what are we going to implement? Okay, let's get this happening. When load to middle, load to end when ready in out. I want to do an unload when ready in out. I want to implement M56. Okay, this one. M56 unload when ready in out. So what states are we going to do? We'll do M56 S speed unload when ready in out. And yeah, 42 is always the answer, Jack's Tech. But 42 is, but 7 is a factor of 42.
Should see Scott's debug line.
Should see Scott's debug line. Yes, I see Scott's debug line. I pasted it into here. It's in here. In fact, I will I'll uncomment it just to see if it compiles next time that I do compile. Speed unload when ready in out. Okay, what states do we want? State unload Ryro begin, and that is going to be 560. And what next is it going to be? So begin, wait, yeah, begin, should we do anything in the begin? The begin could be, yeah, I'm going to make the next one moving. Sorry, I'm thinking through what I'm going to implement in each of these stages. So in the begin, that can check the state of the input, and then it can start moving, and then we're going to do reach, and at that, basically the rest of this is going to be almost the same as cleared, and then we're going to have a run on. So another one here, whoops, run on, and that's going to be Hopefully this will start making sense. I'm doing a terrible job of explaining what's going on in my head. Okay, so we begin in that state. We're going to check for the input to be triggered. If it is, we're going to transition to the moving state. We're then going to get to the end, clear to end, and run on. And most of this is actually going to be a duplicate of this. It's unloading a board and then stopping. And then after that, after the... do we do this once or repeatedly? I think we just do it repeatedly. So we, from the run-on state, we'll transition back to the begin state, which means we are then waiting for the next machine in the chain to say that it's ready. So what I can do is essentially duplicate this state machine and make a minor change. M55 as speed. So where are we? Where's the state machine series for that? So we've got unload now, and I'm going to change that to... oh, these numbers are wrong. This is why I should be using enums or structs to do that. So we've got the unload now block, and I want to go down to here, and I'm going to stick it in there. Where does that begin? Unload now, and then we get down to here. Unload RIRO. Unload RIRO. Begin. Oh yeah, and you can see here that I'm setting the direction explicitly. This is a nasty hack. It's a temporary thing that's obviously going to become permanent because it's temporary. But what I need is a configuration where you can set the default operational direction of the conveyor and not have to set a direction elsewhere. State unload RIRO moving. So what I'm going to do is say if G, so if we're moving to the right, we want the right input to be triggered. So we want ready in right. Now, this is the thing where the terminology for this is ambiguous. It is like TXRX on serial comms. There needs to be a better way of doing this. So this is the ready in right our signal that we are sending out, or is it the incoming signal that's coming from the adjacent machine? Now, I know that this is the signal from the adjacent machine, but it's ambiguous, and ambiguity breaks my brain. Okay, so Jordan says, if you're loading boards based on ready in, ready out, you should stop the conveyor as soon as the entry sensor clears so you can accept multiple boards without special commands. Stop as soon as the entry sensor clears. I think you mean the exit sensor, don't you? So you can accept multiple boards without special commands. Yeah. Although, based on the philosophy of Xeon, we should never have more than... oh, on loading, not unloading. Yeah, thus the conveyor would hold more than one board. Yes, so there are those considerations, but of course there is the philosophy of Xeon, which is never have more than one PCB on a conveyor at a time, because down that path lies madness. So for now, what I'm going to do is run it to the point where the board clears the exit and then stop immediately. And this will deal with... so what you're talking about is a buffering situation, which is... that's going to come, because one of the more complicated things is when we're dealing with boards coming in from the left and going out to the right, and we're communicating in both directions with upstream and downstream devices. Right now I'm only implementing a downstream device, so that if this works, then those other modes that you're talking about, like the buffering modes, they become extensions of this. So I'm building it up one little piece at a time. All right, so state unload RIRO begin. So we've got a direction, we're setting the conveyor speed, and if G ready in right, and then start moving if tripped. I'm just going to fix these, because if I don't fix them now, it's going to state idle. Right, yeah, if I don't fix these now, it's going to bite me. We're going to end up jumping into another part of the state machine unexpectedly. State unload now, cleared end, unload RIRO, cleared end, run on. So the, I probably didn't explain run on, but anyway, I can't be bothered. Run on time, state idle. No, I don't want to go back to state idle. I want to go back to, not state unload now. Have I been, this, I want to go back to this. So that it'll be ready for the next time. State unload RIRO begin, so that it can feed boards on demand. Okay, now, so this is going to be very similar to the timed unload mechanism. The difference is that instead of doing it on a timer, it's going to be doing it on an input when the, actually what I should have done is taken it to the end point. Anyway, this will do for now. I just want to see if this works, and then we can finesse later. Unload timeout, unload RIRO reached end. What does, yeah, I don't think I should be starting immediately. Direction should be stop. Stop, and then here, what I should do is have direction is right. So that if it needs to be in a moving state, it moves to the right. In fact, that I'll just move. Don't even need it there because we're going to a stop state.
It should wait at the end.
Yeah, wait at the end. So do you mean the next board should wait at the, it should queue the next board and have it sitting at the end ready to go? So that's ultimately my objective. But for now, what it's going to be doing is just, it doesn't know where the board is initially. So it's just going to start moving and take and eject or unload one board and then stop. And then cycle around on the next trigger. So we've got state, so that's unload timeout, unload RIRO reached end. So that is fine. So start moving. If it's tripped, then reach end. If it times out, yeah. So if it's reached end and it's untripped, which means that it has cleared the board onto the next machine, then we go to cleared end, and then we do a run on, and then we loop back to do it all over again. Yep. Okay, so Sion said everything should always be waiting at the output position of each stage. Yes. So that's what happens currently with unload timed, for example. So that demo that I did earlier, if I've got a few boards loaded on the machine and it unloads one, it moves the next board to the exit location and then holds it there. So everything is queued up towards the exit. Now that is not actually going to be the case with this little test we're about to run, but we can finesse that. Okay, let's see where the breakage is. What have I screwed up? The compiler will tell me. So, oh, it hasn't exploded yet. There it goes. Oh, it's exploded on that. Okay, well, I'm not even using that, so let's comment that out. And, oops, I inadvertently zoomed out at the same time. All right, upload again. So we're doing a read, ready and left, ready and right, yes, maybe I should use terminology like upstream and downstream. That might make it clearer. So ready in right is the signal coming from the downstream machine to say that it's ready in. So what we could do is say G downstream ready and upstream, yeah, I don't know. Anyway, multiple conveyors for queuing multiple boards. Yeah, potentially. Although that's not particularly space efficient. All right, so connecting to MQTT, doing its thing. So what command did I? Where is this? Let's come back in. Which command am I doing? I want to do, I just implemented M56, didn't I? Unload when ready, in, out. Okay, so we want a command which is M56, yes, 800. I'm just using 800 as speed. So if I send it this command, nothing should happen. All right, here we go. I'm going to switch to the overhead camera and nothing should happen. And nothing happens, which is very good. All right, now with a pair of tweezers, I am going to trigger the sensor, the input, and it should throw one board off. But it didn't. Hang on, was that ready in? Yes, it did not. And it did not do a state transition. All right, time for some debugging. I'll do the other side just in case I screwed it up and I'm reading from the wrong input. Nope. Okay, debugging time, my favorite thing. All right, so this is what happened when I issued the command. We went to state 570 and let's try to be a little bit more efficient with screen. No, not that. I want, okay, so we went to state, hang on, why 570? That's timed. I think I need to, oh, I know, look at this. I didn't change my G-code definitions. Maybe that's just why it didn't work. Load to end immediately, load to middle, load. So what I needed to do was that mcode load to end, and that will be code 53. So I just I told it to go into a mode that, yeah, anyway, you get the idea. 58, 59, load to end when ready in out. When ready in out. And so what did I tell it to do? I told it to do a mcode unload, which isn't or mcode buffer. Anyway, whatever it was a it was like an M code with no defined thing. So it was going to 570, 571, 571, 572. Oh well. Handoff. Upstream and downstream makes sense for a conveyor system, and handoffs is Don S. Yeah, for handoff in a conveyor system. Don said, I use _C for consume, reading an external signal, and P for sending to an external produce. Okay, interesting. Upload failed. I'm going to hit the reset button on it. This is, yeah, these, Austin, if you are still around, I am very curious to know whether you have problems with these WT32SC, whatever they are, touchscreen things, because they just crash
Scott
for me
Miller
all the
said,
time.
Did you actually call the report function for rero?
Did I actually call the report function? I called check this one, check ready in, and that is being checked in loop. Okay, how about now? Is my audio back? I think my Rode wireless microphone went flat, so I just grabbed a backup microphone. Yeah, it should be back now. Okay, so where was I? Marcel Marjon. Yeah, cool. Okay, so what are we doing? Connecting. Yeah, it's just sitting there saying connecting, waiting for download. I'm going to hit reset again. All right, so maybe what I should do is on the next iteration, I should switch to the plus version of the board. I need to rev this hardware anyway. And
Scott Miller said, you checked, but do you report?
I check, but do I report? No, I don't report. All I'm doing is checking it, which is setting the value into a global flag, and then that flag is being checked in the state machine. So it is being checked down here. An error occurred while uploading. Ah, come on. All right, I'm going to try unplugging the port entirely, kill power, turn it back on. Let's just try again. Upload. Austin, so with the plus version, I haven't actually looked at what the differences are. But yeah, it seems like I should probably switch to the plus version if that's what you find is more useful. Ah, cool. Austin says, if you go to the plus, I can send you a template for the controller. For the I/O you need, you'll want to fully change out the MCU board. Okay. Anything you can send me that would be helpful, I would very much appreciate it, Austin. Oh, Plus uses an IPS display, but you get less I/O out, so I swapped the MCU. You swapped the MCU? What do you mean by that? Like the ESP on it? I don't get it. Okay, so where are we here? No, not there. I was trying to get to this window. Okay, connecting to MQTT. So let's try that command again. M56S800. Unknown or empty command ignored. Okay. Mcode unload 56. Oh, maybe I've got to. Oh, yeah. That would help. I want 56 mcode unload. So I want to. I haven't actually defined it in the the parser. So I should do this, mcode unload now. Oh, and there's some debug stuff in the next one. Mcode unload and valid command S, so we're getting a speed. Unload Ryro. Begin. That should do it. Requested speed. S. Set requested speed. Just being called directly anyway. Alright, so I'm going to get rid of that. Going to that. There was some debugging in there. Simplify that. Getting there. Getting there. Austin said, the screen comes with a PCB with a bunch of functions and stuff. I don't normally need them, so I build my own boards and plug directly into the screen. Oh. Okay. I think I can give that a go. Yeah, Austin, so that does sound interesting. I will look up the, where is it? WT32SC01 Plus. I am just pulling it up on here. AliExpress, is this the thing? SC01 Plus. $15. That doesn't sound right. Debugging tool only. That's why. Yeah. Okay. So $48 for the thingamajigamy. Okay. Anyway, I will check that out later. Thanks, Austin. Okay. Next attempt. Let's see what this does. SM. Ooh, it looks like it's crashed. Look at this. It started to do something. I wonder, I'm going to, just in case it hasn't crashed, I'm going to try triggering that ready in signal, and we'll see what happens. Nothing. Oh, hang on. It did a transition. So, all right, back to the console for the debugging purposes. All right, now where are we? So we did a 560 to a 561, then a 1 to a 2. That does not seem right. We have gone... yeah. It's jumping out immediately. So we've gone from an idle to a 560. That would be when I sent the command. Then from a 560 to a 561, 560 to begin and then to moving. So it begins and it waits for the trigger and then it goes to 561. Then it went from 561 to 562, reached end. That is not right. It shouldn't have done the reached end transition. Oh, hang on. Ah, there was a board over the end. Maybe that's what was screwing it up. All right, I'm gonna try that again without actually resetting it or anything. I'm just gonna, in fact, I'm gonna leave this on the screen so that you can see the state transitions, and I'm gonna trigger the input, and we'll see what happens. What happened then? What did happen? No, in fact, I'm going to clear... Oh, yeah, when I put my hand over it, it went from 561 to 562. So it is not running. Segmentation fault, board thrown across the room. It's 12 o'clock. What? All right, I want to get this working. I want to get this one mode working before the stream ends, but I do have to go and buy that guitar. So, what are we ending up in? I'm going to clear this. So we are in state 560. right now. I'm going to clear it, and then I'm going to trigger. So there's currently nothing that is over that sensor on the end, so it doesn't think there is a board there yet. I am going to trigger the input and we'll see what transition happens. Okay, so we just went from 560 to 561. In 561 it should be moving, but it's not. So I've screwed up somewhere down in the state machine. Where is it? Unload here. Set conveyor speed, GX direction equals right. So right now it should be moving. Why is it not moving? Set conveyor motor speed, and it should be moving at 800 millimeters a second. Is it because where is that G code? Let's come back down to here. Perform requested, set requested speed, set requested speed, set requested speed to that, parse G code parameter. Why am I doing set requested, set conveyor motor speed? Okay, your requested speed should be set. Alright, what happens with the timed unload? So we're setting direction is right, but we're doing it in the begin. And I don't want to do it in the begin. I want to do it while state unload timed moving tripped. Direction is stopped. Yeah, I think the problem is right around here somewhere, because we're not transitioning yet. We're at this point, oh, it's timed out. Look at this. So it thinks that it was running for 30 seconds and it has hit its timeout and it has gone back to its default state. So we would need to issue a new command to put that back into unload mode. So we've got, oh yeah, and it would have been 56 seconds from boot before I triggered that input. So somehow it is not running the motor when it should. Setting GX direction is right and set conveyor motor speed, which was previously happening in here. I wonder if the stop, let's get rid of that. I wonder if that is clearing, like if I had a look in the G code parser. No, I'm just gonna, I'll have that uploading while. Did the motor get unplugged, says Jordan? That's actually a really good question. It could just physically be unplugged because these connections are dodgy. No, it looks like it's plugged in. I believe it's plugged in. Should be okay. Yeah, setting the direction to stop. Now we're in motors. Set requested speed. Setting direction. Yeah, anyway, I'm not gonna. Guitar, says Don S. Yeah. Ah, you stupid thing. It's died again. I'm going to hit reset on it. These boards just crash constantly. I don't know why. I don't have this problem with other ESP32 based boards, but these, yeah, Scott says try one of the known working commands. Yeah, I will do that after this upload. Yeah, these particular boards just crash if they're running for more than a few minutes at a time. Okay, attempting connection. Oh, that's just because I hit reset. No, compiling, come on, upload. Upload work this time.
Austin's_creations said, show the serial monitor from the reset crash.
Oh, from the reset crash. There was nothing on it. Failed to upload. Yeah, all right. So the way, when it gets into this stupid state, I have to unplug USB and plug it back in. and then hopefully it'll work. I wonder if they're doing, yeah, this is an old style ESP32. I wonder if it is because it's the USB to serial converter chip on this board. It's probably using some piece of crap like a CH340G, and that's why I have all of these intermittent upload problems. Doesn't explain all the crashes though. So doing it with something like a, yeah, that was the guitar guy. So doing it with something like an ESP32S3 would be nicer with a more modern processor. And attempting connection. Okay, it's uploaded. So let's try this now. I'm going to try this command. All right, it's there, and now I'm going to trigger the input. It's done the transition, but the thing is not running. Okay, so now I'm going to send an M5 command, which is a stop. Then I will do the timed unload command.
Austin's_creations said uses CP2104.
Ah, CP2104. Okay, well those are good. So that shouldn't be a problem. Where was it? What was the timed unload thing that I was doing before? Although the code will have changed. Conveyor stop. Yeah, that timeout happened. So request status. I want to do a timed unload at a timed interval, M57. Okay, so let's do M57 S800 P5. And it's not running. That's interesting. Yes, yes. The motors are not running. So whoever it was that suggested doing a known good command, yeah, Scott, try one of the known working commands. That was a good call. It is not, the motors are not turning.
Bork, bork, bork.
Yeah. And then it just did its timeout because it failed to get the board to the end. So why is it not making the motor turn? Setting speed, setting that. Am I just screwing up and setting, hang on, S800 P5, M57, processing M57 S800 P5. Yeah, it's going to take more debugging, but I'm going to do that later because I need to go to Blackburn and yeah, and then do some more plastering, I think. So remember everybody, no barbecue next week is the decision, but there will soon be a web page which will be superhouse.tv/barbecue, where all of the information about the barbecues that are coming up will be posted. So pay attention to that one. Motor have power? I don't know. I'm gonna have to do some debugging after this, but yeah, I can't do it right now because I've got to go and grab that guitar. So thank you very much everybody for coming along, and yeah, Mr. Fixit says debugging requires concentration. It is hard to do debugging and talk continuously and not allow any dead air. So I will figure that out, and I'll be back next week. So thank you very much, and see you later.